this session. Uh, yeah, so from this session, I guarantee you that you will take a learning and a curiosity from this specific topic and technology that I'm going to cover. And then I would definitely connect with you after this session if you have any questions, and if you have any follow-up questions that I could cover as a session, because I wanted to compress this session. And this was for beginners. I combined a lot of details in together, the lot of things I coupled together. So this is going to be very short one, short session with a demo. I will be sharing my screen, setting up the full, like, very scratch environment, very new environment on my local machine, and I'll show you like very simple infrastructure code, how to create your own stuff, and then we'll go from there. We'll have a lot of things there, as we speak about it. So I'll need to share my screen and then have some material that I'm going to share with you at the end of this session, or I'll share with Ditiksha ma'am, so you can connect with her, and then you can collect all the things from her. So let me know when you see my screen, and we'll get started from there. All right, if someone can just give me thumbs up if they can see
Yeah,
my.
we can see your screen. Yeah.
Okay, perfect. All right, so today's topic, we are going to talk about containerization, and what is really this containerization and how is it really different. I'll also, in between, when I go and switch my screens and all, I'll also turn off my camera, because it's just much easier for me to demonstrate when I'm not looking at myself. So containerization, let's quickly talk about containerization. What is this containerization technology that that I'm going to cover here? And then I'm going to take Docker containers, um, in my example. So I'm just going to skip this because I was already introduced, and I don't think I can combine. I can really introduce myself the way how Madam really introduced. So let's get started. So basically, today's session, I'm going to cover introduction of Docker. What is Docker? What is container? And then very simple workflow, SDLC workflow. Those who are very new, SDLC stands for Software Development Lifecycle, meaning when we develop any program, when we create any program, and we create that as a product and then shipping that product to the customer, the entire life cycle of that software is software development lifecycle. It has multiple stages, phases. I'm going to cover that later on. How this SDLC is applicable here in the Docker architecture. We are going to also install Docker while when we are on a call. So those who are connecting from their laptop, those who have their own personal laptop, feel free to just install when we talk about it. So if you face any problem, we'll just troubleshoot right here. We will also cover some custom Docker files. What is a Docker file? We'll talk about it. Some Docker build compose, and then we will deploy our container locally. So let's see. What is the traditional application development approach? There is a challenge when we have a when we have a monolithic architecture, monolithic environment. Like, let's take this example. The class of 40 people, 40 students. We want to build something. We want to create some software. We all can have a different operating system. We all can have a different programming language, experience. We all can have a different perspective of building specific application, and so on, right? There is so much diversity in building any specific software. So what happens in this kind of scenario? We have to manually install a lot of dependency. Like all these people who are working on specific software, they have to install, maintain their dependency, ship their dependency, and then when it comes to operating system, some dependencies are there, compatible, some dependencies are there not compatible. You have to it's very tightly coupled with the software and operating system that you're going to use. This is like a traditional approach that we see in most of development in most of the development project. And then it's really hard when it comes to setting up this complex setup, like installing the dev environment, production environment. We are going to run this live and shipping this our product from local to live. It comes to that uh, pain for the engineer. And it also it increases the risk of human error, configuration issues, and a lot of debugging problems. And it may stretch your shipping timeline. It may increase your timeline, the estimated timeline for the delivery. So how this technology, how this Docker containerization actually solve that problem? The life of engineer without Docker. First, as I mentioned, uh, engineers will create their application code, whatever it is. Let's say web application. Then they will install their required dependencies, like let's say PHP, MySQL, or JavaScript, or whatever. Like it could be anything. Let's say another developer is building web application in Python, building a Python, installing the Python, and then some other libraries and so on, right? And then they test it locally. They test on the machine, then they ship it. Once they ship it, it's now they will we will like the team will start preparing the development of sorry deployment of this build. Now it comes to installing all the requirements, all the dependency on the production servers, maintaining everything, and then deploy the application the way how engineers built it. If there is a dependency, if there is a tightly coupling between three different applications, let's say there are two databases and two web applications. Now one web application is depending on one database, but then second web application is depending on the another database, but then both databases are connected. It's like it's tightly coupled to each other. So it's really hard to manage all this when you are running service, when you are running production system, and when you are running, let's say, AI, when you are running OpenAI, when you are running very critical workflows, when you are running security firewalls, it's really hard. So what happens in this case when engineer they use Docker? They build a code, you build a Docker file with the image. You have a proper image with your whatever application code that you built. Now that package that you have, you can just imagine, you can just copy paste anywhere. You can just install anywhere, deploy anywhere, and it would have a same exact replica. It would have a same exact copy wherever you deploy. If it's a dev, test, production, anywhere in pre-production, anywhere. If you're running in Linux, if you're running in Windows, it would have its own package. So you do not have to worry about the dependency, configurations, all those things. And that's the value that Docker adds to your application development. So now we spoke about like how it's different, like how the life is different when you're using Docker. So let's see, what is Docker really? And how is it really different than any other things that we have? Any other things, meaning we have virtualization, we have software as a solution, we have so many other things. And how is it different? So Docker is a virtualization software that packages your application. It simplifies the application development, and then the dependency management, and then your lot of libraries and all those things. It simplifies your development and deployment. It combines all together. So containers are nothing but it includes everything. It includes from the application that you build to all different type of dependencies. Let's say you have a hardcore operating system level dependency, you have a library dependency, you have some specific version, software version different dependency. It combines, the container contains all of it together. So when you are shipping your code, you're shipping your package to somewhere, and that's where this technology really helps to maintain and make a scalable and reliable environment. And that's pretty much what we do. So container is application plus dependency that tightly coupled with the application. Then all your configurations, all your environment variables, your system tools. Let's say there are some debugging tools you require, um, and there are some health checks, endpoints, and whatever things are required with your application other than your part of application, you can combine all together. You can then package it with your operating system runtime, and then you can ship it. And then once you ship it, it's it's the same experience you had when you were developing. You'll have the same experience when you're deploying it in production. um, any questions, by the way? Any questions so far? Anyone? I was expecting one question, and probably I'll have somewhere here. How is it really different than virtualization? How is it really different than Hyper-V or VirtualBox or VMware? How is it really different than that? You could just create the image of your operating system and then do the similar thing with it. So how is it really different? Um, and I'm going to explain why is it different. It's architecturally different. The functionality is different. The way how both the technology it works very differently. So let's say first we'll start from the left side, leftmost image, which is talking about virtual management. Sorry, virtual machine architecture. There you have. We'll start from the bottom. So we'll have you have this host OS, which is your machine OS. You have your hypervisor, the layer of hypervisor, which is operating system, which is a connection or connection bridge between your operating system and virtual systems. Then on top of hypervisor, you have the hypervisor plane. You have a different virtual machines. It contains its own operating system. It contains its own library and binaries, and it will contain its own application. Now here versus the next to it, let's now talk about the Docker architecture, how that Docker architecture works. So you have a host operating system, then you have a Docker engine, and then you have a you have application slash binary slash library slash operating system, guest operating system, all combined together. And then you have that container which is calling everything, or which is using everything, consuming everything. So the way how here I see how it's simplifying the setup, it also, okay, the setup of the overall architecture, it simplifies that. Second, it simplifies the patching or Windows update, or anything like any updates, security updates. It simplifies that because you don't need to patch each and every VMs now. You can just patch your Docker image, and I'll show you later on how is it going to really go into the action. And of course, it's because the container works at it's a package, it works all together. The startup time is very low, it's very fast, it's like very lightweighted. Containers are very lightweighted. It's not like you're rebooting, you're installing any specific patch on your machine, on your operating system. The machine installs everything and then reboots it and then continuously reboots it, whatever, and then comes back after, let's say, 10 minutes. You can't really wait 10 minutes when you're running, mission critical service. When you're running healthcare system, you can't just go 10 minutes, you can't really hit on 10 minutes downtime. So that this is the risk that you are carrying when you are using virtual machine, and that's where the Docker will help you. And let's understand this Docker architecture a little bit. more, we are zooming in the Docker architecture. So here the Docker, for this example, for our use case, there are a lot of, by the way, there are in market, there are a lot of containerization application or containerization, what we call the solutions out there. It's available like Kubernetes. There is a Docker container. There is a, service fabric. There are multiple other possible solutions are available. I'm choosing here Docker because it's open source. You guys can just download, use it, learn it by yourself, contribute to it, and that's a good starting point. So that's why I'm using that. In industry, we use different type of solution, but it's all based on the container. So the concepts are clear. You can learn all those other technologies later on. So let's zoom in a little bit, Docker architecture, and then it includes Docker engine, some core services, which creates and maintain manages containerization. And then there are two different parts of it. Now everyone is looking for GUI, everyone is looking for user interface, and everyone wants to look wants to use a fancy UI, and that's why they support UI also, they support GUI also. CLI is of course traditional approach, it's already there. And CLI GUI, for to maintain and manage Docker resources, so Docker cluster. When so in this specific diagram, you can see that there is a client, there is a host, Docker host, and there is a registry. There are three different uh, area, and these three are a major components. These are three core components. We will start with a client. So Docker client, it could be GUI or CLI, and from there you can just send instruction to the Docker host to do certain activity. When you are building your application, when you are developing something, the client is something that you will use. Docker client is something that you will use, and then you'll send instruction to the Docker host to do or apply certain configuration based on whatever development you are doing. um, Docker host contains, some daemons, Docker core services, some networking services, operating system services, and then routing services, DNS services. There are multiple other core services. Important part to consider here is, there is a containers, there is a container section, and then there is an image section. Images here are nothing but operating system image, and we'll talk about this in the next slide, because I have very specific example here to how to use and how to use and manage this different images in your container. And in previous slide I mentioned, you the container is nothing but the combined package of your dependency applications, operating system, configurations all together. You're creating a package as a developer, and then you are shipping it to the team, and they are just going to deploy this on the Docker cluster, and then they'll just create a container from it. And when I said you're shipping those things, when you're shipping to the team, you're there are two ways. You could probably just share your code over some CI/CD. You could show CI/CD pipelines. You could share your code in pen drive or anything, or Google Drive, or probably GitHub, and any other solution. At the same time, you could, when you have a package, you could actually you could compile it, you could build a specific image itself, like an application image, and you can ship to the registry. So registry is nothing but a different image registry. It's a database of, or it's just like a directory. It's just a database of all the images. And you as an author, you as a developer, because it's open source, you can just create your account, developer's account, and you can push your custom images to this registry. And that's how it's very useful. This entire solution is very useful and very fast because development, deployment, configuration, all these steps are it's just expediting the process. And it also decreases the risk of human error. And ah, this is my favorite part. So let's now quickly um, you know uh, install docker docker on your machine. And let's quickly explore. Let's see what's here. And you can just go to this www.docker.com, and then under the download option, you should see official uh, desktop Docker desktop binary. You can just download that based on whatever operating system you have. You have Linux, install Linux. You have Windows, use Windows. If you have Apple, use Mac. Whatever option you have, I think all the versions are available, so use that. And let's install it because the next section is more about now using it, exploring. We will explore this Docker container service, how it looks like, and what are the features that it provides, and how to use it. um yeah, and then if you I'll give a few minutes, probably 5 minutes. So use this time to install, set up this, going through the installation instruction. And if you face any problem, just maybe speak up, or just put it in the chat. I'll respond here. I'll give 5 minutes break here to install and then set up your Docker container. All right, we'll resume. If anyone has any questions, if they are facing any issue, just put it in the chat. So if you install your Docker, you should see like the desktop version, something like this. And I for this session I installed this fresh image, fresh Docker binary. So when I'm starting this Docker for the first time, it asks for the service agreement, Just say yes, accept. And after accepting it, yeah, I don't care, just skip it. Don't care. No need to provide any data to open source. And this should the Docker engine should look it should just like set up all your environment, all your local settings basically, and it should apply all these things for your uh, local development environment, and then just wait for some time. And then for first time it takes little time. Later on, it should be pretty fast. Yeah, and also and go to settings and then general settings. Make sure to use WSL2 based engine. If you are using um, Windows operating system, make sure to enable this. This is nothing but uh, Windows System Linux, I believe. It's a Linux Windows-based Linux image, which is available or integrated for Docker on Windows. So make sure to enable this if it's not enabled. Okay, cool. So as you can see, now my Docker engine is running. Um, so the cluster, what happens is when you install this Docker desktop solution, it install those multiple components that we discussed, Docker client and Docker hub and the Docker system, the overall environment, which we call uh, Docker cluster. So cluster contains multiple things, and then we will quickly just explore those things. We will start from images. These are the images that I was talking about. So currently my image, these are my uh, local images. So there are no images right now because this is a fresh, and hub repository is also not connected. You could just sign in and connect. This is your own hub repository. You could create a repository, but we'll explore that later on. Image After image we have volumes. This is nothing but your disk volume. You could have a temporary volume. You could have a persistent volume. You can have any different type of volume partition for your images for your application, and this is where you can create and maintain. Then you have your build. When you are building your own application, we are continuously changing. This is where you are keeping your build history. And let's say something is broken and you're troubleshooting, you go back from here and then see where did you really break your binary. And this is why you could use this build functionality. And then we have a Docker hub. This Docker hub is open source repository where you can find out all different type of I'm sorry. This is where you could find all different type of Docker images, pre-built images, and you can just set up, you can just install, configure on your own, and then you can modify on top of whatever images are available here. Scout. these are the different features, and you could like install lot of different extensions. You can create different except extension. I'm not going to speak about this. You can explore on your own. um, uh, because the idea here is to now create your own container. So we will use this. So this is a basic um, utility, like when after installation, when you see for the first time, everything is fresh right now. So what we will do now, let's quickly go back, and then we will create our own now. Screen. Da, 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 da. All right. So let's understand now, where this Docker SDLC, like how Docker comes, when Docker comes into the picture, how software development lifecycle workflow looks like. So normal developer, when you have you just started your development, you just started setting up your application. From that point on only, you'll start creating your Docker file. You'll start maintaining your Docker file, and that Docker file you will use in your local environment on your local machine. So for the local host, you'll just use the Docker image, uh, Docker file, to configure your container, to deploy your container locally, and then you'll just start building your application. Once you have it, once you are satisfied with your app, and let's say you want to release that app, you can create the Docker image and push it to the Docker container. From there, when you are creating Docker image, you're pushing it to the Docker hub, and from Docker hub, you could configure all your different environment to pull always latest image from the Docker hub from your repository. So you can configure your different environments. Let's say hypothetically you have a Docker hub where you have your repository. Repository is nothing but a folder. Under folder you can have a sub repository, where you can create, uh, let's say, staging, dev, pre-prod, all different type of environments there, environment specific folders. And then you ship your Docker image to the Docker hub, to those subfolders. And from there, these different environments, they pull images that you pushed, that you published, and it will continuously deploy and configure in your production staging or testing environment. So that's like pretty much like how the automation, CI/CD automation looks like, or SDLC, um, SDLC phase or workflow look like for the Docker based development. Um, all right, let's see. And let's see now, because we talked about Docker image registry a lot, Docker Hub a lot. So let's explore what is it, and how it's going to help you. Um, I hope you see uh, my browser screen. And by default, Docker Hub registry does not require any authentication. And this is how it looks like when you open it. Let's just search about, search for anything, anything here. Um, those who are familiar with Kali Linux, let's search for Kali Linux, and you'll find lot of different type of images. Um, people Developers, they created their own image, and then if you go to this specific trusted tag, you'll find different type of image. um, that different organization created and then acquired this different type of tag or certificate. Um, let's search for MySQL, and you'll find this is okay. So that has a tag Docker official image, meaning Docker community. They created this community created this MySQL database image, and let's explore what is this Docker MySQL image. And it has a maintain by, it has some details, metadata, tags. Here tags are nothing but a version, and you'll always find latest tag, meaning it's a default tag. And you'll see some details here like source code and how to run, how to like what are the commands that supports, if it has any specific user default user password, all those things, all these details you'll find out here on this like on readme file only. But in our example, I'm going to use Nginx. Uh, do you guys familiar with Nginx? What is Nginx? I hope you must have heard about web services, different type of web services like Apache, and then IIS server. There are multiple other web services are available. Web servers are available, and Nginx is one of a kind, and it's very flexible, compatible, and it's also very advanced. It supports a lot of security features and a lot of great features comparing to other web servers. And I would highly recommend if this is very new to you, I would highly recommend to see Nginx, how to configure, how to use it, and when to use, um, because most of the industry uh, use this Nginx. So let's explore what is Nginx. And under Nginx, you can see this different tags are available. You can you can just see how you can pull this image, how you can download this image. So I'll just go here. Let's now open command. In our environment, this is our Docker hub based on the architecture that I explained earlier. This is our cluster, local cluster. And when I install Docker desktop, I should also have my um, Docker client also, which is CLI. And this is nothing but version 27.4. So Docker, when I run Docker CLI, it will tell you exactly. It's very much like it's very documented. Like it has very rich documentation. So each and every commands were documented very clearly. And if you have any problem, you can talk to the community and they'll answer. And you have a lot of commands here. And then when you see the command that this site have mentioned, it's a pull command. So I'll just say docker pull. And as you can see, docker pull has this command where you have option, name, and then tag. um, I'll just say this. And by default, as I mentioned earlier, default tag is a latest tag, and every image should have that tag. So by default, when you do not mention tag, it will always look for the latest image and it will download. So now, as you can see, it downloaded a latest Nginx image, and it made it available to your library. So now let's go back to the Docker, and then let's go to images. And this is the image that I'm talking about. And it downloaded, it configured a lot of things here, right? And let's go back and then see the size of this image. This was 200 gigs, 278, sorry, 278 MB. Just imagine running this in production when you have to maintain operating system, dedicated servers, patching, all that. You have to you have to maintain like a full-fledged machine, full-fledged server, with so many dependencies and so much space. And here you have Nginx within few minutes. Image is available now, and let's see now how we can use this image. Now I pulled pre-built image which someone created. Here in our case, author is Nginx community itself. So they created this image, default image, and then they just shared image on the machine. Sorry, on the registry. So let's see what happens now. So after pulling the image, I will look for Docker images, and that should show me the same exact thing which I was showing here on the desktop. I don't like it GUI, and it's just easier and faster when we use CLI. So I'll just go from here, and then we will use CLI and then see um, what what we can do with this. So let's just say Docker run Nginx. What does it do really? It creates a container from the image that you pulled locally, all right, and it configures with the default configuration that is available to the Docker image. So when I go here, there are some default configuration available, and those configuration like this one, like I'll explain what are those configuration, but essentially, like there are some network configurations and operating system level configurations, etc., etc. Those are things, the couple of things are available there, and then it's going to run that container with the specific image configuration. So when I go to the container now, I should see some container, and let's see, it does not have any port exposed here. As you can see, there is no port here. Okay, cool. No worries. Let's go and exit. And this time I will say, those who are familiar with PS command, this will show you if there are any if there are any containers are running, any active container. So there are no containers because I just stopped. But let's say there was a command run nginx. If I just add dash d after run, which is detached. D stands for detached or daemon. It creates a background process, and then it just continuously runs that process. And now, if I see Docker PS, then I should see a container, and there is a container running. 80 port is open. Okay, cool. There is something open. So let's go here and look for localhost. Huh. Okay. It didn't work. Why? Just for those who uses IP address. Huh, it didn't work. Why? Hmm. Okay, cool. It didn't work because this is a container port. You are creating a container, listening that container on 80 port. But the way how this Docker architecture or Docker network works, you have to expose this port on your host also. And that is the important part. And how do you do that? You could run. Let's first go here and then kill this first of all. So Docker stop and then container ID. It should stop it. And see, there is no container. And then this time I will use the same command. But in my case, I will say p/p, let's say 80 port. And then I know that, okay, this is host port or target port, and then later on this is your container port. So on 80 port, I know that this was listening earlier. So I'll just say this and then run it. And what's gonna happen now if I say PS? Okay, it did not run. Why? I know. Windows operating system, I am using actually Windows 11 and not running my not running my user profile as an admin. So I cannot run 80 port or less than I think some number of ports. So in this example, just so that this can work, I will use some other port like 40,000 port, just a random port. And then if I see, let me see if this works. 1 second, I might have made some mistake here. Oh, okay, I see. Okay, this is not working because it's looking for the specific application. What I did was just a pulled server. It's not going to run the server before till I provide a specific entry point or a specific app applications. So let's just create a like fresh application. It should be like very simple application. So we will just go here. Let's go and then create this application. Let's call Docker. All right. And create this simple file. We are going to call Docker file. Okay, as you can see, it creates a txt file. So make sure that it does not create txt file because Docker files should not have extension. So in case your operating system is messing up with extensions, make sure that you should just replace your extension. Just remove your extension because you need just a Docker file. It should not have any extension. All right, let's go here and then open it quickly. And before, yep, I'm going to just say from Nginx and then Alpine. This is nothing but operating system. I'll just show where is it really mentioned. How am I really writing this code? So if I go here, then Alpine. If I look for Alpine, like these different type of operating systems are available and using one of those. So probably let's say if you have this, right? This is where you can mention your Nginx specific version and then your app version, operating system version. So I have something that I pulled and made it available on my personal repo. So that's why I'm just going to use this latest without version, which will take latest only. Then let's say now we are going to expose 80 port here, and then I'm going to say CMD. I'm going to explain what are these commands. What is this really, um, and how to create this? What's the guideline here to create this? Just give me 1 second. I'm going to explain one by one. What does this mean? Right, so we have this. Now let's go here, open terminal here. And we will say docker build t, and then we'll give just a simple name. So Nginx app, it doesn't really matter. Whatever name you're adding here, it's a build name. So we'll just say here, take this as a reference. When I say dot, it's going to take Docker file from the same directory, and it's going to pull Docker images. And then the way how I'm configuring here, this is very simple configuration. Now I'm going to explain what are these. So couple of steps here to create this kind of Docker container image. We'll come back here on the networking part, but in order to understand this, you need to understand these commands. So there is a cheat sheet. There are specific commands and there are some specific instructions available to create your Docker file, and then you can use that. You can use those commands to create your container, your package, and once the package is ready, then you can deploy it anywhere. So I'm using these commands from this cheat sheet. It's available on the docker.com, and you can search for Docker file command cheat sheet, and then you will find this. And then later on, once you have it, you can build it. And once you build it, you can see when you run images, you'll see that your custom image is now created. So now, as you can see, the size of both the images, like how I have my when I'm creating a custom image, I'm actually not pulling every single thing that is available on the Docker registry for that Nginx, but still leveraging Nginx and then creating my own application. So let's now say Docker run, and um, P stands for port, exposing port, some port, and then running on 80 port because I'm exposing on 80 port, and then app name is Nginx app. If I run this, then this is how it looks like. Then if you have to allow it from the app directive daemon in the command line. Is it my Windows that is not allowing? 1 second, let me quickly just disable firewall. Probably my Windows is not allowing. All right, let's try again. There you go. And let's say now Docker, this still not allowing. Is it allowing now? Local host dot. No, not 4,000, 40,000. Probably my Windows is still not allowing. So let's go for further, little bit further, and then try to put some code here. Probably this is why it's not allowing. I'll go here and then create a simple HTML file. It does not need to be very fancy. So I'll just create here simple HTML file. Text.html. Sure. And let's say Ta-ta. Okay. And because I have now that files, I need to copy those files. Um, so before exposing, I need to copy dot files src index.html to user, then share nginx html index.html. All these details, by the way, the path and all, right? Where am I grabbing all these details? This is all documented here. If you look here, you'll find all these details like configurations and how to create this entry points. All these details you will find here in official documentation. You can leverage that documentation and then create however, like create the file however you want. All right, let's try now. Did I save this? Probably not. I'll save it again. Build it again. And this will build the file again. Let's run this. If magically if it works. Mhm. Okay, let's see. Let's quickly just try to troubleshoot here. What's happening here? What's going on here? Thirty seconds. Deleting all other containers. If it's creating any conflict, hopefully it's not creating any conflict, but also possible that I'm running this as a normal user. Let me try running this as an admin. Mhm. Running both as an admin now. Let's run it again. Hmm. Human is in the command line. I see. Okay. Yep. I made a mistake here. It's it was a typo, and that is why it was not working. So see how you could see all the logs, and then let's create image again because you need to rebuild. Uh, you need to rebuild whenever you are making any changes to your Docker file. And then let's run this again. Docker, Docker PS. There you go. Finally. So Docker logs. I'll just quickly see here. And there I can see, okay, cool, it's doing something. Let's go here and refresh this, and there you go. So do you see like how it's easy, how easy it is to even troubleshoot when you make a human error right now in the local, just like how I did. It's really easy to just go and troubleshoot and go into the Docker and Docker logs, and then you can clearly see the instructions in for the troubleshooting purpose. And then this is where Docker is really helpful, because just imagine running a critical service and you want to create this kind of service and you want to troubleshoot quickly as fast as possible. Let's go back, and now you will understand few other concepts. Um, we'll quickly just cover those concepts. I already covered these things, by the way. Understanding the container, we already talked about this. We already use these commands. And port binding, what I just did, uh, the I what I did, I binded the 80 port from the container port to the target host port. That is nothing but a port binding. The way how it works, there is a host operating system. The outer layer is host, and then the inner object here is a container. You can see that it creates its own independent network, and under one virtual network, and then you have a Docker router. It works as a router or a proxy or a bridge, whatever you want to call, and that is directly connecting to your it's connected to your host operating system's Ethernet, and that is how it's communicating your host Ethernet. And when you are setting binding at the Docker uh, proxy level. So when you okay, now I just gave a demo with a very simple web application like HTML or PHP. You can just have that kind of this kind of logic and create a Docker file, custom Docker file, and then create a full-fledged application, full-fledged stack, where you have API, web app, you have your own, let's say, IDS system even within part of the package, and then you can have a database system, you can have a database client also within the container. You can combine all this together, and that is where you require basic some networking, some basic Docker networking, and you can create these different Docker networks within the file itself. There are commands: create a network file, network configuration, create like a DHCP subnets, and then you can create shared folders, shared files, and all that. And then you can share across your different type of applications. So this was the example, very simple example. But let's say you have web application, web container having two different type of Ethernet ports, and then one port is available through the host, but another port is not directly available through the port. It's available through some kind of gateway servers or some kind of channel. So in this is a very real world example. Your application front end, let's say one of the port is available or API port is available through the host, but another backend system is connected to DB, and DB is behind your network. So DB is not connected on, and it's not exposed outside, and that is why you have another Ethernet port, or you have a VPN connection in between your DB and your web app, and then you can maintain that network like a isolated or a dedicated network. And these are like different type of complex networking you can apply, and then you can just maintain this very easily with the configuration. And the data management, I just mentioned about, like you can create and mount these volumes. And we talked about the commands already. We spoke about the commands. We also created our custom file. So what we did, we pulled the operating system image from the registry. Then we copy the HTML file. In our example, it was just a very simple HTML file. It can be anything. Like you can have your binaries, you can compile your code and then push it, and Python file or whatever. Then you can pull all the dependency to run the binary. You are setting all your environmental variables. Then you are creating the container resources like networks, let's say volumes, and like multiple other things. There are so many other things, and then you create your application artifacts. Configurations like app setting configurations or proxy settings and all that. Once you have everything, you build your Docker image, you test it locally. If it runs perfectly, you deploy it. You just deploy it as your new build, your pre-built image. One other command that I forgot, when I pulled different image and then I created my HTML file hosted locally, I could also push that image. I could make it available for all other people through the Docker Hub, and that's the centralized feature that a Docker Hub registry provides. You can not just pull the image and maintain it; you can push it also to your registry. You can create your registry and you can push it, and you can contribute because it's open source. And couple of common commands where we use docker pull, docker run, docker ps, docker stop, docker start, docker rm, which is deleting, delete the container. Here, one disclaimer: when you are deleting container, you are deleting only container. You are not deleting the image, which is uh, which is which is created or which is pulled from your registry initially to create container. And this is where we will quickly talk about the recap. So we understood what is container, how do we use it, why do we need it, and some introduction, some architectural diagrams, some features of Docker container and Docker Hub, Docker CLI, Docker cluster, container cluster, and then how to pull, run, debug container. Luckily, I had an issue and I could just show you how to debug container. So that is cool because that was not part of the session. And how you can create your custom image, how you can create and push your custom image. We also talked about, we also used these basic commands, which are like super handy. If you have it handy, you can just debug everything within a minute. Um, Couple of other things that you have later on, and I'm not going to combine those two things together like this is where the beginner session ends, and these are the other things that you can consider on your own and you can explore. So Docker Compose is something you can explore on your own. Now that if you understood Docker file and Docker based container, you can explore Docker Compose. What is Docker Compose? You can have a multi containers. Imagine hundred of containers you can create within one big file, giant file, and you can compose all together where you have a different dependencies, like interdependencies, internet container dependency, or external dependencies on all that. So you can create that Docker Compose file, which is nothing but an orchestration file for your Docker containers. Some best practices: make sure you use lightweight image and not super, like, heavy loaded image. Make sure you have a very, like, minimized number of layers, dependencies. The lesser the dependency you have, lesser the headache you'll carry in the production. That's the thumb of that's the first rule of the thumb. All right. And then just regular update your image, look for the security patches, and some improvements, because you'll always end up finding a bug. And um, and what else you could do, like, for the security consideration: run your containers with least permission in production. All these containers are maintained and run by service accounts and not human accounts. In industry, humans are not directly touching or running these containers or maintaining clusters. It's all maintained, managed by automation. So make sure you scan your image, before before even deploying or using it locally. Just like there are so many contributors to the open source, there are so many script kiddies creating malicious files, malicious stock containers, and then pushing it. So always watch, always be curious, but also be cautious. And explore CI/CD for yourself. For explore CI/CD for container. And the one topic that I did not mention earlier, Swarm. Docker Swarm is for auto scaling or clustering, auto scaling, it helps you to keep your cluster healthy and reliable all the time by applying either auto scaling, let's say horizontally or vertically. And Yeah, this is where it can help. And then how to monitor Docker containers. That's also something that you could explore later on. And once you understand Docker, just I'm just putting out here, and then when I'm sharing this presentation, this is also there. Something that is like a next step after you understand Docker. What is microservices architecture? Kubernetes, Docker, Azure, how it's all combined together, which is Azure Kubernetes Service, Git for CI/CD, how to use it, and then what templatizations for the cluster. Couple of references I provided here. Uh, I would say Docker's official documentation is so rich. So those whoever looking for any help, look for community help, and you'll find very good documentation, very good help, uh, enough help from the community people. And I think that's all. Thank you very much. This is my profile. So those whoever want to talk about session, have any questions, reach out to me for any help, any way I could help. Uh, I mentor. I also share a lot of industrial learnings with academia, as well as early career, those who are in early career. So I help them. I will help you also. Reach out to me on LinkedIn. I'm usually responsive on LinkedIn, so you'll find me on LinkedIn. And I think that's all for today. Any questions? Any comments? There are some things here in the chat. Let me see.
Yeah, students, if you can ask if you have any question, or you can share your feedback if you learn something new.
Yeah,
IoT, CSE students.
yeah. By the way, there are IoT students. I didn't know actually there are IoT students. A lot of IoT applications are like home assistants, and there are so many different lightweight applications uh, supports Docker. So I run my own home network on Docker system. I have my own home assistant, or like a home smart house system, where I use Docker Docker with there is some specific protocol that I'm forgetting right now, but there is a peer-to-peer connection protocol and Bluetooth protocol that I use to maintain and manage home automation, like garage door, based on my geolocation, or timer based um sprinklers, garden lights, all those things. So I use Docker a lot. So those who are in IoT, this is like definitely a great tool for you to explore and then put it in your profile. And yes, you can create your custom CI/CD pipeline. You can use GitHub, you can use GitLab, you can use Azure DevOps, Jenkins. There are multiple other platforms are available. What you need to do is use this Docker. Docker file. This Docker file is your source code of your container or source code of your infrastructure, and you'll combine with your application code. Both things you will push to your CI pipeline, I would say, because then after once you have a CI, continuous integration. So what you will do, you'll use on if you're using GitHub, let's say, you'll create this you'll use this Docker client or Docker build. It's all available on Azure DevOps. I know at least Azure DevOps that it's available, and you can use those on a runtime. Let's say on a main branch, when when any updates are coming to the main branch, you are running a build on your Docker container, and then you're creating a image. Later on, you are pushing that image to the hub, Docker hub, and then from so that is your CI part now. For the delivery part, now for the delivery, what's going to happen is you are combining. Sorry, you are from different environments. You are pulling those images from the registry. You must have heard about uh, this is a common registry, but this is very specific to Docker registry. But you must have heard about Azure registry. There is a Azure DevOps registry, then AWS registry. There are so many registry platforms are available, and you can create that registry. Configuring You can configure those registry with your environment, and then you just need to push your image. So once you push the image, all the environments will continuously take the binaries from the registry. You do not want to touch production from the CI pipelines, because you do not want any developers to touch the production directly by just shipping the code, because they could ship bugs also together. So yeah, that's a very good point. Someone, I think Vaibhav mentioned this path for DevOps engineer. At this point, there are very few jobs available, or very few, I would say, very few roles are available in DevOps role. They combine this DevOps role with the infrastructure or system engineering role together, and they call site reliability or service reliability role, which is combining of DevOps, which is DevOps lifecycle, as well as improvement in the system, improvement in the like system level development, system level management, and then patch management, security management, all those things. So they, and also performance management, performance testing, chaos engineering. There are so many things, PKI metrics, all those things. They combine all these duties together, and they create industry. I'm talking about when I say they, I'm talking about FANG. They created this different role now a few years back, site reliability or service reliability role, and that combines this duties, roles, skill set all together. Did I answer your question, Yash, or do you have any other question? Thanks, Ria, for mentioning. I should have checked messages earlier. I did not see this message earlier, so I had to troubleshoot. Thank you. Any other question? If you understand container, then you may want to look for now how you can monitor container, how you can manage container easily, and how you can orchestrate container easily and templatize that container. All these skill sets, if you combine together, that uh, that 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 gives you a good understanding from the scratch, building the application to shipping it out to the customer.
Yeah, so students, I have put the attendance and feedback link in the chat box so you all can fill it up so that you can get the attendance as well. You can ask if you have any other question. I think, yes, we can end the session if the students are not having any query, or I think they can reach out to you afterwards as well.
Yeah, absolutely.
Yeah, okay. So
All right.
thank you
Thank
so
you.
much for joining and giving us this much of time, apart from like we are not sharing the same time zone.
No, I was looking forward for this session. Please share your feedback with Ditaksha ma'am.
Yeah, definitely. I'll
I
share it with you as well. So from the
Yeah,
Department of Computer Science and Engineering, Cybersecurity and Internet of Things, I appreciate your time and your efforts you have provided us for this particular session, and we hope that in future also we'll be having some of the more sessions related to this topic.
yeah, absolutely. And
Students, you can reach out to directly Yash or me.
yeah,
You have any query or any feedback, please provide. Despite having so much busy schedule, as you see, he's also pursuing PhD in security. He is having his own organization, is contributing in the NGO itself. He's working in Microsoft in a new role. Then too, he has provided us the time. So please appreciate his efforts and provide the good feedback. Thank you so much, Yash.
thank you for everyone for attending. And then yeah, all the best. The session. I hope you learn something from this session, and then take that as a starting point. Take that curiosity, and then uh, just try to build your own application. Try to build your own infrastructure. Yeah, thank you.
Yeah, thank you so much. So I'm ending up the meeting here. Please provide the feedback and the attendance on the provided Google form. I have provided the link again. Neve, let me check caution. B students, now you can see the option is available. B students, please see. Thank you so much all for joining. I'm ending up the meeting here. Thank you.